Public health, HIV, and social justice. We have a problem. HIV, or human immunodeficiency virus, is an issue attacking the health of humanity, for which there is no cure. Approximately 37.9 million people across the globe have HIV. According to the World Health Organization, 770,000 people died from HIV in 2018. Having HIV reduces your quality of life. A person living with HIV has to deal with a range of HIV-related symptoms for longer periods. People with HIV have a harder time attending to daily tasks, participating in extensive exercise, and have lower energy overall. Also, many HIV patients struggle with stigma, depression, substance abuse, and more, which all contribute to a decreased quality of life. While antiretroviral therapy, or ART, exists for HIV, it does not cure the disease. It changes HIV from being a fatal illness to a potentially manageable disease. However, that is not good enough to ease those who have contracted HIV. Meet Leo. He is 9 years old and has HIV, which was passed down from his mother. He has had a decreased quality of life since the moment he was born. The only way to ease him is to cure his disease. Our job is to develop a drug that will cure HIV. A cure for HIV would decrease the burdens on the health of the global population and would improve public health everywhere.
As we are well aware, HIV is extremely widespread and increasing in transmission. Displayed above here is HIV protease, the protein that's activity is involved in HIV. Now, if you look in the middle of this protein, you can see the active site. The active site is the region of an enzyme or protein where a substrate molecule binds and undergoes a chemical reaction. Therefore, this place in the protein is extremely important. Now, if you look at the red and blue regions of this protein, you'll see red, meaning regions that are polar acidic, and blue, regions that are polar basic. And this plays an essential role in interactions of other proteins. Displayed next are the different residues of HIV protease. Now, this may sound confusing, but these are essentially just different regions of the protein that interact and act differently. So some of those amino acids, like glycine for example, GLY, is a residue that's highly soluble in water and is said to be a polar molecule. Therefore, these different residues, depending on what the amino acid is, have different interactions. But in more basic terms, we want to develop a drug that will interact with regions of the protein and ultimately disrupt its function. So that's why it's super important to understand what each region does and how it acts. In fact, that's what a drug does. It goes into the body and disrupts the function of the protein or the particular protein for that disease. In this case, we want to disrupt the function of HIV protease. Now, our job is to figure out how to do that. Now, after spending countless hours in the lab, as you can see here in our videos, we decided to use a method called nanotechnology in order to deliver our drug. Now, nanotechnology is exactly what it sounds. It's a very tiny tool that is used to deliver the drug and actually interact with the HIV protease. Our hope is that this drug developed will ultimately disrupt the function of the HIV protease and help those with HIV to have a better quality of life. We hope that this drug will not only improve the quality of life of those suffering from HIV, but also help improve society and the public as a whole, so that young boys like Leo and all individuals suffering from HIV will have a better quality of life.